Hey Luke, how's it going?
Hey, how's it going, Mr. Holman?
Good. You just working on your physics?
Yeah, it's kind of confusing.
Yeah, elementary particles can do that. How about this? How about you come and step over into my office?
Okay, yeah.
Matter as we know it is made up of what we would call elementary particles. These elementary particles are, as per our current understanding, the way our universe works, the way our universe is built. First, primarily, we have it divided into two different categories. We have hadrons and leptons. We also have gauge bosons, but we'll start with hadrons. Hadrons are all made of quarks. There are 6 different types of quarks. There is an up quark, a strange quark, a top quark, a down quark, a charm quark, and a bottom quark. They're kind of funny names, but those 6 quarks make up the vast majority of the world around us. These 6 quarks have a charge, the same kind of electrical and magnetic charge that we've been talking about all year. The up, strange, and top quark have a plus 2/3 charge, and the down, charm, and bottom have a minus 1/3 charge. So they work together to make up all of the hadrons.
Oh crap! Totally forgot! Oh man, it's so bright. Forgot I gotta talk about physics. Mom! Mom!
Yes, honey!
What the heck was I supposed to be talking about in physics again today?
Something about hadron particles? Hadron?
Oh crap, it's the hadron particles. That's right, so in physics there's 2 different things. There's hadrons, and so there's baryons and there's mesons. And baryons have 3 quarks, while mesons have 1 quark, and I think it's 1 antiquark. Yeah, that's right. Anyways, there's so many mesons out there in the world, but they're typically not very long lasting because they're sort of unstable. But baryons have 3 quarks apiece. There's 2 main ones of those, and you know them as protons and neutrons. Now the protons have up, down quarks and down, up quarks. And so an up, down, if you think about it, that's plus 2/3, and minus 1/3. You do the math, that's something like 1. So that's a positive 1 charge for a proton, and then you do a neutron and you have negative 1/3 plus negative 1/3 plus 2/3. And you think about that one, that gives you 0. That's how your neutrons have equal charge. There's some other baryons out there, but they're far less common than protons and neutrons, as they often come from the less stable quarks. I'm going back to bed.
Honey, come do the dishes!
Damn it, Mom! I'm not doing the frickin' dishes!
Oh, hello. I didn't see you there. Okay, as Sam mentioned, hadrons and leptons are 2 main categories of these elementary particles. While hadrons are made out of quarks, leptons are actually their own basic elementary particles. There are 6 main leptons: the electron, the mu, the tau, and each of those has a neutrino, which is neutral charge, while each of those has a negative 1 charge. And the electron, mu, and tau all have antiparticles. Along with hadrons and leptons, there's also gauge bosons. Gauge bosons carry the 4 fundamental forces: electromagnetic, gravity, strong and weak nuclear forces. The electromagnetic force is carried by photons, while gravity is carried by gluons. W and Z gauge bosons carry the weak nuclear force.
While the chart above displays the organization of elementary particles, it's important to note that the true elementary particles are quarks, leptons, and those gauge boson particles, including gluons, photons, WZ particles. These 16 elementary particles form the basis of matter in the universe. According to current physics, they are the smallest building blocks of matter. Of course, these particles have their own rules to govern them.
All particles have antiparticles, and when they meet up, they cancel each other out in a process called annihilation. In this process, it creates gamma energy.
In all nuclear and particle reactions, momentum, angular momentum, mass and energy, electric charge, baryon number, and lepton number are all conserved.
A good number of elementary particles are not stable. As for the hadrons, only the up and down particles are stable. For the leptrons, only the electrons and the neutrinos are stable. For the gauge bosons, only the gluons and photons are stable. If a particle is not stable, it will decay into energy.
Quarks cannot exist independently, making them pretty hard to study alone.
See, and that's how elementary particles work.
Wow! I totally get it now. That's awesome. I totally understand.